Hello guys, so today we are going to discuss another sorting algorithm, that is bubble sort, right? So what bubble sort says that if you are given any unsorted sequence of integers, so what bubble sort algorithm will do, it will just try to bubble up the largest possible number in the whole unsorted sequence, right? So here you can see that currently in this unsorted sequence 5 is going to be the largest number. So what bubble sort will do, bubble sort will try to just place this largest number from the unsorted sequence to its best possible position, right? So it will just place it to the best possible position. So what bubble sort will ensure that after each iteration, whatever the unsorted part is left, we will just make sure that the maximum of that unsorted part is going towards its best possible position after every iteration, right? So it will just bubble up, it will just try to make sure that these integers are getting bubble up to the best possible positions in the sorted sequence, right? So let's see what is the basic intuition behind bubble sort, right? So suppose that you are given any unsorted sequence. Suppose you have an unsorted part from a sequence. Suppose this is a1 a2 till the position am, and after that if you start from m plus 1 am plus 2 till an, which is a sorted part. So this is a sorted region and this is the unsorted region. So what we are going to do, we will just make sure that inside this sorted part, this is going to be the minimum element, right? Inside this sorted part, this is going to be the minimum element, and say inside this unsorted part we have some element x as the maximum element, right? So what we will try to ensure that after each iteration, whatever the division is, we will make sure that this minimum element of this sorted part is every time greater than the maximum element of this unsorted part, right? And what we are going to do at each iteration, we will just pick out this maximum element and put it to its best position. So if this maximum element is just smaller than this minimum element of the sorted part, then what will be the best possible position after the whole sequence is sorted for this maximum element? It will be just behind this am plus 1 element. So we will try to just place x here, right? So at each iteration we will just divide our array into two parts. In the initial iterations, the whole array will be considered as the unsorted part and the size of the sorted part will be 0. And after the complete sorting algorithm has been executed, this sorted part will be equal to the size of the array and the size of the unsorted part will become equals to 0, right? So let us just see how a basic dry run and see that how we can just apply bubble sort in the following case, right? So suppose the array given to you is 5, 4, 3, 2, 1. So here you can see that this array is arranged in the descending order. So if it is 5, 4, 3, 2, 1, right? So at each iteration, what we are going to do, we will just keep a tracker I as well as a tracker j, right? We will just keep a tracker j. So now what we are ensuring that if the current element which I is pointing, if it is greater than the just next adjacent element, then we will just swap these two elements, right? So here you can see 5 and 4 will be swapped and 4 will come here, 5 will come here, right? Now I will be incremented. Let's say just we are just keeping things on a simpler note by keeping just I as our variable. Now I is pointing to 5. Now I will be compared with I plus 1th index, and here you can see that 5 is greater than 3. So again we will just swap things from here to here. So here you can see this is 3 and this is 5. Now again 5 will be compared with 2, and here you can see it will again be swapped. So 2 will come here, 5 will come here. After that 5 will be swapped with 1. So this will be like this sequence, right? Now again we will just start I from the very 0th index, that is this one, and now here you can see when 4 and 3 will be compared, 4 will be greater than 3, so we will just swap 4 and 3, right? So 4 and 3 will be swapped and 3 will come here and 4 will come here. Again 4 and 2 will be swapped, so 2 will come here and 4 will be swapped to here, and again 4 and 1 will be swapped, so these two come here. So again here you can see that we just picked out 4 as the maximum element from the unsorted part, and we just placed 4 at its best position. So at each iteration, at least one of the element is getting placed at its best possible position. Now if you compare 3, so here you can see we will start again from I is equals to 0. We will compare I with the next corresponding element. So here you can see 3 and 2 will be compared. So 2 will come here and 3 will come here. Again 3 and 1 will be swapped. So here you can see 3 and 1 are going to be swapped. So 1 comes here and 3 comes here. And now if we just compare 3 and 4, so no swapping will occur because 3 is lesser than 4. Now at last what will happen is we will just compare 2 and 1. So 1 will come here, 2 will come here. 2 is also present at its best position, and at last 1 is also present at its best position. So here you can see that we just at every iteration we were just bubbling up the maximum possible element from the unsorted sequence, and we just place this bubble to the sorted part, right? And at last the size of this sorted part will grow up till the size of the original array, right? So let us just see that how we can just implement this algorithm. So what we are supposed to do, we can just try to mimic the same algorithm in the code. Like we will just have one pointer which will be pointing to the first position, right? And what we can say is we can just have a variable which can just keep a track on the fact that if we are sometimes swapping an element or not, right? So here you can see when 5 was present here and 4 was present here, you can see that when we were just swapping both the elements, we know that swapping will occur only in those times when the some part of the array is unsorted, right? But if the whole array is already sorted, then obviously no swapping will occur. So we can just keep a variable that can just track the fact that if we are swapping some element or not, and if in the whole iteration if we are not doing any kind of swapping, then obviously the whole sequence is sorted and there is no point of reiterating to the whole sequence again and again, right? So let us just try to think in this manner only. So we will just keep a track on a flag. That is, suppose we are keeping a flag track on the done flag. So initially what we can suppose is this done flag is marked as what? False, right? And what we can do is while this flag is false, right? While this flag is false, we will just try to implement the algorithm. Now what the algorithm will say, suppose at each iteration I will mark this flag as true, right? I will mark this flag as true, and if at any time any swapping will occur, I will just change the flag to false again and the loop will be implemented again, right? Now we will start from I is equals to 0, and what we can do is while I is less than n minus 1, right? We will just go till the last index and we will just check that if array at I is greater than array at I plus 1, then what we can do is we can just swap the element present at the ith index with the element present at the I plus 1th index. And as I said that if any one swapping is also occurring, then also we are just sorting, then also we are at an unsorted sequence and we are supposed to sort the sequence. So we will just again mark this done variable as false, right? We will just mark this as false. We will just close this if loop if conditional and increment the value of I, right? So here you can see that as soon as we will just come at this while loop, we will just check that if we are greater than our adjacent element, and if that is the case, then we will just swap myself and just change the variable of the done flag, right? So here you can see that if the sequence is already sorted, suppose that sequence is like 1 2 3 4, so here you can see that the sequence is already sorted. We will start with the done variable as false. We will check that while not done, that is while the value of done is false, we will mark the value of done as true. So we will just mark the value of done as true, right? We will start the variable I is equals to 0. We will check that while I is less than n minus 1, we will check if I is greater than the adjacent element. So here you can see 1 is not greater than the adjacent element. So this if conditional will not be executed. I will be incremented. Now I will become equal to 1. So 2 will be compared to 3. Again, no if conditional check will execute. Now I will become 2. 3 is not greater than 4. 3 is lesser than 4. So again, this conditional will not be executed and we will just come out to the while loop. Now here you can see that after we just came out to the while loop, the value of this done variable is true. So if we will just try to reiterate in this corresponding while loop, then obviously this while loop will terminate. This while loop will terminate as soon as we have got our whole array as sorted. So what happens in the case of bubble sort is if the array is already sorted, right? So no swapping generally occurs and we can just in linear time check that the whole array is getting sorted. But in the worst case, what can happen is we can get an unsorted kind of sequence, and in this unsorted kind of sequence, every time we are starting from this very first index and going till the last index, right? We can even optimize this approach by not iterating till the last index. Why? Because we know that at the first iteration the largest number will be present at its best possible position, that is last. After the second iteration, the second largest number will be present at its best position, that is second last, and so on. So we can just reduce the searching part, the searching space at every corresponding iteration. But let us say that in the worst case we are just iterating to all the n sequences, so the number of iteration will lead to the complexity of big O of n square in asymptotic notation. While in the best case, this is going to be a linear kind of scenario. In the best case, the bubble sort algorithm will run in linear time, that is big O of n, right? So I hope the logic for the bubble sort algorithm is clear to you all. This is one of the very fundamental algorithm in sorting algorithms, and this will lay down the concepts of more sorting algorithm for you guys, right? So I hope you like the lecture, and if you have any suggestion, you can just put them down in the comment section. We will meet in the next video. So thank you guys. See you next time.